Yes, we see, we hear, and we glad to see you
I'm glad
and
to
to
see
hear
you
you.
too. Dear
So,
colleagues, dear participant of the conference, I present to your attention a report on the topic the data dissemination planning task process model into account the entities differentity. This report was made by the team of the authors. It is I, Serhiy Semenov, Serhiy Inhalychev, Vyacheslav Lamarenko. It is professional from Cybersecurity and Information Technologies Department of Simon Kuznets, Kharkiv National University of Economics, and Professor Svetlana Gavrilenko, the Computer Engineering and Programming Department of National Technical University, Kharkiv Polytechnic Institute. My report have some question. You can see this question on slide number 2. It is introduction, analysis of Ukraine and other modern scientific sources, generalized job scheduling model and entities with dependencies, mathematical model for scheduling data dissemination task. The result of the study, these mathematical models in conclusions. If I speak about introduction, I can speak the information service range expansion in cloud environments, the increasing interest in network and computer resources on the part of modern society, as well as the growth in the number of their consumers causes and objective need to solve their problems in increasing the efficiency of using these resources. But a lot of IT company, IT organization use a lot of solve for different technologies. It is computer class, it's a grid system and cloud system, it's a lot of else. At the same time, the analysis of distributed data processing system as well as protocols and algorithms for their functioning show significant limitations that reduce the efficiency of information exchange and data processing process. These limitations are caused by the heterogeneity of the processing object as well as the fuzziness of the input data about the entities. These factors impose additional restriction on the entity description model and require the improvement of existing task scheduler to handle them. One moment. The purpose of the study is to improve the data dissemination task scheduler model, taking into account the heterogeneity of entities. When modeling, it is necessary to provide for the use of additional blocks for analyzing and adaptation entities to the existing capabilities of processor and other resources. The analysis of literature made it possible to present a block diagram of the flow of entities for planning system in the form of figure number 1 in this slide. In the a lot of article on this basic of the above figure, that concept of an entity was substantiated and visualized within enters the input of the planning system and consists of a set of tasks. As can be seen from this figure, task tree enters the input queue. At the same time, tasks are the minimum planning unit. Within a single entity, jobs can be classified into independent jobs and organized into a generalized structure called a dependency tree. Accordingly, such entities can be executed independently of each other or sequentially if there are dependencies. Dependencies defined on the order in which work is performed and the flow of data between entities. An analysis of some literature, a lot of literature shows that various service disciplines can be used in practice to plan tasks. At the same time, the conducted studies made it possible to single out those service disciplines that are supported by the expert environment as the main ones in solving the problems of planning and managing computer resources, while taking into account the need to process entities of a different structure. These are disciplines such as FIFO, LIFO, RSS, and else. The conducted studies have shown that despite the practical relevance of the service disciplines, they are not without a number of shortcomings associated with the assumption of the same time of task in terms of requirements for computing information and other resources, as well as the lack of flexibility in evaluation, job handlers, and entities. At the same time, underestimation of these shortcomings leads to a decrease in the efficiency of using computer resources in case of heterogeneity of task scheduler nodes, heterogeneity of the computational and spatial complexity of the task and entities themselves, the possibility of parallel data processing when scheduling tasks. The conducting resource showed that on the one hand, the above disadvantages of not taking into account the heterogeneity of job and entities can be eliminated by using such a service discipline as discipline short job first, where the task with the lowest resource requirements of the short remaining processing time discipline, where a task is selected for which the estimated service time is minimal. However, the need for a priority date on resource requirements significantly limits the possibilities for the practical use of those disciplines. Another important aspect of the considered task scheduling model is the storage of data on the status of task execution. This in many ways allows you to interrupt the execution of the current task and switch to the execution of another higher priority task. Such disciplines as time sharing, least attained service, short remaining processor time belong to this class of task scheduler models. Therefore, each computing model has the ability to process several entities at different stage of execution. Starting date on the state of task execution is widely used for scheduling processes in operation system when several processes are sequentially allocated a quantum of processor time to create pseudo-parallelism. However, this strategy introduced additional overhead and may not be suitable for interrupting computationally intensive tasks. Considering the next stage of planning, it can be noted that for each selected task, you can use node selection procedures, which determine the required amount of resources for data processing tasks. This allows you to build a planning process taking into account the state of each node, as well as in accordance with the preset application requirements. The disciplines of assigning nodes to tasks can also differ from each other depending on the available priority information. At first, it is less used now. Second, random selection. Estimate the remaining execution time. Prediction of resource consumption. A significant drawback of the above planning disciplines is the consideration of the task selected process and the not selected process as independent stage of planning. The initial selection of the highest priority task followed by the quasi-optimal selection of the node. Despite the fact that at each individual stage a quasi-optimal decision is made, in general, the process of distributing a set of tasks in a set of nodes is often far from optimal. To search for a quasi-optimal assignment of a group of tasks to a group of nodes, it is required to consider the indicated planning procedure within one stage. Schematically, the models and methods of task planning can be represented in the form of figure in slide number 5. It is a figure. Let's study the presented scheme using the mathematical formalization of the planning process for the dissemination problems. To do this, we use the methods of GERT network modeling. On next slide, you can see figure the GERT network of the process of scheduling distribution tasks for a separate set of date tape is tape. Sorry, the use of the Manson formulas made it possible to represent the equivalent wave function of the execution time of the studied task scheduling process in the form of an expression number 1, this slide number 6. Studies have shown that the main disadvantage of such a scheme is the inefficient or use of resources, and not in the case of calling and processing heterogeneous data. This is due to the lack of the possibility of preliminary analysis of resources capabilities and nodes in order to fill the remaining parts of the processor capabilities of computer system for processing heterogeneous data. Based on the presented result of the analysis, it can be concluded that it is necessary to improve task scheduling model in distributed data processing system. First of all, this is caused by the objectively existing condition of heterogeneity of input data and entities. It is expanded to carry out this improvement by introducing into the scheme on slide number 7. This slide, on this slide, you can see additional block of preliminary analysis and adoption of heterogeneous entity, which will also perform the function of adapting the processing used in it for processing entities to the internal capabilities of computer resources. This should make it possible to reduce the time spent on performing applied data processing tests. To solve the problem, we transform in this scheme the task scheduler scheme, slide number 7. Based on proposed, next slide. Based on the proposed concept of using additional procedures for preliminary analysis and adoption of heterogeneous entities, the GERT model is transformed into a network structure in figure on slide number 8. At the same time, the equivalent W function of the execution time of the improved process of scheduling date dissemination task, taking into account the possibilities of analysis and adoption of heterogeneous entities, can be represented as the expression number one, the slide. The use of the proposed equivalent W function in the future will allow use to determine the analytical expression for calculated the time span in the implementation of an improved job and entity scheduling process. The conducted studies of the task scheduling process and entities made it possible to form the characteristics of the branches considered in the GERT model, and the distribution parameter and presented them in table number 1, slide number 9. This table, you can see the model branch characteristics. In accordance with the characteristics of the branch of the GET network, the equivalent W function of scheduling time for task and entity considering heterogeneity can be represented as expression number 1, slide number 10. Let's find the probability distribution density of the scheduling time for dissemination task of a separate set of date type. In this case, we define the following parameters of the branch of the GERT network as initial date, who can see in slide number 11. And for this case, figure shows a graph on the probability density distribution of the scheduling time for propagation task of a separate set of date type. As can be seen from this graph, the maximum values of the probability distribution density of the scheduling task for the distribution of a separate set of date type under condition of heterogeneity of entities fall within the interval from 0.08 to 0.17 TR. And finished, I can see conclusion the report. Thus, a model of the process of planning the task of date dissemination has been developed, and distinctive feature of this model is taking into account the heterogeneity of entities by including additional block of their analysis and adaptation to the existing capabilities of processor and other resources. This made it possible to determine the main probability temporal characteristic of the process. Future research will reduce time cost and improve the efficiency of using existing resources of computer system. In addition, the improvement of models and methods for analyzing and adapting entities for existing capabilities and resources of computer system will make it possible to substantiate their practical applicability and improve a number of characteristics of the function of a computer system. Thank you for attention. I can hear your question.
Thank you very much for your presentation. And please, question, colleagues.
Alexander is here. Thank you for presentation, Sergey. I can see that the problem you try to solve is actually a problem of classical superscalar architecture of existing processors. How do you deal with non-coherent data for different processes you try to schedule.
Alexander, sorry, repeat it, please. I can. Second question.
How do you deal with non-coherent data?
Okay.
In your proposed model.
Okay. I can answer this question. We can use a lot of methods. I think in future use methods fuzzy GERT network. It will do a lot of plus because I can see some border with big data with date. I can use my knowledge about this border, about different with date. I can I can take into account this different with date in this model.
Okay. Any other questions? No. Thank you very much, Professor Simonov, for your presentation. And let's